Hey guys, today I'm going to show you how to do CSMC 2021 Part 8 Problem 6 a different way, because I know we took this up in class, but I didn't like the solution that Warlow provided, because I just feel like it's really messy, and there has to be a better way. Because what they use here is this point G, and they drew a bunch of right angle triangles, and they use similar triangle arguments, which works. But yeah, I just feel like it was a little messy to draw. So I'm gonna show you how you could use the Stewart's theorem on triangle PCB and find a relation between this between like this length and this length using Stewart's theorem. So Stewart's theorem is basically a theorem involving Cevian and triangles. So Cevian is basically the vertex of a triangle and it touches the opposite side of the triangle. So there's a relation between the sides of the triangle and the Cevian. Cevian is basically this angle D, this line D over here. And how people memorize this, the relationship, is with a mnemonic. Basically, a man and his dad put a bomb in the sink for some reason. All right, so that's just how people memorize it. And how you can memorize the position actually is also quite simple. So you have this same side, n times m, and then times the whole thing. That's man. And then dad, you have the Cevian times this whole length, and then times the Cevian again. And that's one side. And then bomb is b. You memorize basically the importance of memorizing the position of where all the variables are instead of just memorizing this is because when you have a problem like this where the Cevian is rotated at a different angle, it would be kind of hard to know which variable is which, right? But if you memorize the position, it'd be way easier to use. So b times m times b, basically b, you choose one length and then you go to the other length. You cross the Cevian, you go to the other length, and then you come back, and then the same thing. You choose C, go to the opposite length, and you come back C and C, and that's basically the theorem. And this is derived from the law of cosines. If people are interested, there's a lot of videos online. And actually, we have a special case of the Stewart theorem, which is called the Polonius theorem, and it's the formula is a little simpler, but I feel like you can probably just memorize this and get away with it in life. Okay, you don't really need to memorize this, but this formula is a little simpler. And the Polonius theorem, it applies when the Cevian is as you can see in this picture, it's cutting the opposite half into two equal sections, which is exactly what we have here. So in this triangle, PCB, MB is the Cevian, and it cuts PM and MC equally, right? Because M is the midpoint. So this formula also applies. And no matter which formula you use, you will end up with the same thing. So it doesn't really matter. So now I'm going to set some notation based on how we're gonna use this theorem. So n is gonna be the length between PM and MC, right? And so PB is equal to PC and PDPA. So PB would just be 2n, and then DC and CB would be length A, and that's what we're trying to find. X is the slant height of the pyramid, H is the height of the pyramid, and it's also an important observation to know that MB is also A, MB and MD. Yeah, I actually didn't see this when I was doing a problem like 10, 11 months ago, I forgot. But essentially, since they provided that DMB is a right angle triangle, right? BMD is a right angle triangle, and you know DCB is obviously also a right angle triangle, and they share the same hypotenuse, which is DB, which means they must be similar. Okay, I mean congruent. Sorry, they must be congruent triangles. So DMB and DCB, so they're congruent, which means MB and CB, they have the same length. And this simplifies the problem immensely, because then you can use and we only have two unknowns basically. So now let's just apply the theorem, right? Insert everything, all the variables. So you have n times 2n, which is this section right here, n times 2n, this entire length, plus a squared times 2n equals a squared times n plus 2n times n times 2n. Okay, and then you want to, this is a squared? Yeah, that's just a squared. And then you want to simplify 2n squared plus 2n a squared equals 2, sorry, this is 2n cubed, and this is squared, not cubed. A squared n plus 4n cubed. You can factor n out of here, and the reason why I chose to factor n instead of anything else, because I want to cancel them on both sides. 2n squared plus 2a squared plus 4n squared. So now I can cancel both sides, and then if you arrange this, you get 2n squared is equal to a squared. So yeah, this is the formula that we're gonna this is the relation that's gonna be useful. And the next step is to think about the problem like more broadly, which is kind of the thought process that they had here. Basically, the triangle that they cut is 1/4 of the volume of the whole triangle. Oh, sorry, the pyramid that they cut is 1/4 of the volume of the whole pyramid, because this length, over here. Sorry, I'm gonna start again. So the area of a pyramid is the base times the height, and then times 1/3. So okay, you know what? We can write this down. A squared. So this is a volume of the pyramid. And what's the volume? How do you express this volume? The height is 1/2 of this height, right? Let's call this height h2. h2 is 1/2 of this blue h, like the big triangle. And the area of the small triangle is also 1/2 of the big area. So it'd be 1/2 times 1/2, which is just 1/4. Okay, so 1/4 of the pyramid. So this area here is 1/4 of the entire pyramid. So and then the problem states that the volume of the remaining solid is 288. So the remaining solid is just 3/4 of the entire area. So sorry, the entire volume. So this would just be expressed as the area times the height divided by 4. So this is equal to 288. Right. And then, so let's go on to the next step. And how do we find the height? So to find the height, we need to, there's this triangle over here. Alright, so P, let's call this O. PO, what a pain. Okay, let's call this N. doesn't matter. So this, basically this triangle over here, we can use triangle because we can find x. We can find the slanted height, because the slanted height is really just this. We can use this triangle, sorry, for the slanted height. So this triangle is a right triangle, and we know everything. Okay, so this triangle, we're going to use this triangle. So the height, the hypotenuse is 2n, right? So 2n squared equals, and then one of the sides is a over 2 squared plus x squared. We're gonna call the slanted height x squared. I don't know why I put this in parentheses. Oh yeah, okay. So this be 4n squared equals a squared over 4 plus x squared. And the important part is using this relationship that we found. This can be broken down as 2 times 2n squared. And 2n squared we found is a squared. So this is actually just 2a squared is equal to a squared plus 4, divided by 4 plus x squared. So you can solve that x squared is equal to 7 over 4 a squared. Sorry, my 7's ugly. I'm writing on a mouse again. And you actually don't need to solve for x, because we're going to plug this x directly into this formula. This other triangle with Pythagorean. So 7 over 4 a squared is equal to h squared plus a over 2 squared. Okay, I'm going to skip some algebra. So h would be root 3 over 2a. Okay? And now you come here. You have this formula. You know h in terms of a. So just solve for a, because a is really what you're looking for. So a squared h 4 equals 288. Whoops. A squared root 3 over 2 a equals, let's remove the 4. I don't like fractions. A cubed root 3 over 2 equal to 1152. You punch everything in a calculator, and remember it has to be like a improper form. It can't be decimals. So yeah, just keep that in mind. A would be 4 root 6, and that's the answer right over here. Oh god, can't even circle. Yeah, right here. Right, thanks for watching.